Our firm was brought into the project about a year before design started. Thomas & Williamson, the project management team, construction management team, has a relationship with us, and they were involved already in a few other projects in the school district, adding the air conditioning systems through traditional means, the 4-pipe unit ventilator systems. In preparation for this project, they wanted to look into if there was an alternative that would both be cost effective and perhaps a little less invasive for this design. So what we did was we're brought on to put together a study looking at both the traditional systems and some alternatives. Yeah, one of the reasons I think Thomas & Williamson came to us was that in the area we were not traditionally doing a lot of K through 12. They wanted someone who could think a little outside the box and do a true honest study on whether or not the traditional systems or there were some new systems out there that could be used. In our case, we took a look at the baseline systems, which were the 4-pipe unit ventilators that the school district had been putting in to add the air conditioning. We also looked at a 2-pipe changeover, and then some separate systems with terminal space conditioning units. Specifically, we looked at chilled beam options and the VRF options. Dehumidification was a key component to both the study and subsequent design. Typically, space conditioning systems, DX in particular, only dehumidify a portion of each hour. ASHRAE, of course, recommends that dehumidification not allow for 60% relative humidity most of the time, and DX systems are not particularly good at constant dehumidification on the terminal side. And so in our case, we wanted to make sure we had 100% outside air ventilation system, and that ventilation system had to dehumidify at all hours. The key to that is then a reheat that was important to the ultimate design choice. Specifying an HVAC system to this particular school was slightly challenging in that the entire project was the air conditioning retrofit. So the goal was minimally invasive construction. And in this particular case, there were no pipe tunnels and similar type systems that other schools may have had in the district, and they wanted to be able to install the air conditioning without this complete disruption. So for that reason, VRF made perfect sense. We were able to install space conditioning systems merely by placing them in ceiling tiles, provide ventilation systems using the Mitsubishi DOAS systems, which were localized ventilation to 2 or 3 classrooms so that the controls were contained, the school was zoned, and very minimally invasive installation. Well, for this project, VRF made perfect sense. We wanted to have space conditioning through ceiling cassettes in a minimally invasive fashion. Specifically, Mitsubishi coupled that offering with a dedicated outside air offering that met our needs. What we did was took 2 or 3 classrooms and had a dedicated ventilation system complete with the energy recovery and free hot gas reheat to provide constant ventilation to each classroom in small, digestible, controllable zones. The ability to control each zone with its own space conditioning thermostat and to be able to tie that to the Mitsubishi dedicated outside air system, which when serving 2 or 3 zones had the ability to act as the first stage of cooling, first stage of heating, or to provide neutral temperature dehumidified air and to allow the Mitsubishi cassettes to do the space conditioning as a package was the obvious choice for this project. As a design engineer, Mitsubishi offers active local representation, local training, software training to really allow the designer to optimize systems from the design standpoint. In addition, the contractors also seem to find that Mitsubishi is the preferred product, making it easier to design around Mitsubishi. There were so few problems on the project that there weren't very many anecdotal stories to recount. The contractor was able to acquire the equipment in a timely fashion, install the equipment in a timely fashion, and a lot of the construction was done during the school year, and we're able to complete the installation after hours without really disrupting the school. Well, we didn't realize it at the time, but apparently we have the largest installation of Mitsubishi City Multi-Dedicated Outside Air Systems in the United States. In addition, we have a lot of rooftop equipment that is supported solely on non-penetrating roof supports, which again cut down on the general construction required for the installation. What we were able to do at Westview is just the beginning. We have since taken the design and made it even better moving forward. We now have projects that are no longer relying on the existing heating systems. We can actually take what we learned at Westview and apply it to year-round comfort in other schools. The controllability is second to none when combined with the local dedicated outside air systems. The success of this project has really helped change our thinking on what systems should be expected to be applied for elementary schools. We were able to take what we learned here and evolve the controllability of the systems, evolve the installation of the systems. The school district response has been very positive. Oftentimes, there is no response until I ask, how are things going? The lack of issues has created an atmosphere where they sometimes forget they have a new system. It's virtually maintenance-free for them, and the comfort, the noise is satisfying each classroom. And that's typical of these projects. The feedback is so minimal because no one has problems with the system. So there's not much feedback on them.